Okay, here's the graph of y equals x squared, this red graph. Here's the line y equals 81. Notice that the point of intersection is at 9, 81. So this is the region we want to rotate around this green dashed line, the axis of revolution. Now, the problem suggests or gives you a hint that you use the washer method, which means our typical are perpendicular to the axis of revolution. So we need to solve this equation right here for x in terms of y. So for each y between 0 and 81, if we take the square root of that y, we'll get this x coordinate right here. So this graph right here can also be written as x equals the square root of y, or y to the 1/2. Okay. Now I'm going to go to Desmos, and I'm going to enable finding the volume of the region, the volume of the solid that's created when this region is revolved about the x-axis. This green dash, or this black line, is representing a typical washer. And you can see that as I go from 0 up to 81, the length of that washer gets longer and longer. We're creating infinitely many of those washers. But if I revolve that washer about the y-axis, I'll have a very thin cylinder. And the volume of that cylinder will be pi times the radius squared times its height, which will be a very small delta y. And that's what this is right here on row 12. Pi times the definite integral from 0 to a dot y, that's the 81, of the radius, which is the length of this washer right here, the radius of this washer, squared. And you can see in subsequent steps that I've changed this to y to the 1/2 squared, which is y. So the antiderivative of this part is 1/2 y squared. So the value of the definite integral is g of 80, big G of 81 minus big G of 0, which is 6,561 over 2. And if I multiply that by pi, I get 6,561 pi divided by 2, or about 10,306 cubic units. Okay, now just to convince you that this can also be done by the shell method, in this case, your typical shells are parallel to the axis of revolution. And you can picture another part of the shell over here and revolving that around. We get like an open can. And the volume of that can is 2 pi times the average radius, which is just x, the distance from the axis of revolution to the center of that shell, times the height of the shell, which is the y-coordinate at the top is 81, the y-coordinate at the bottom is f of x. And if I substitute x squared for f of x and then distribute the x, there's the same thing. So the antiderivative, 81 halves x squared minus 1/4 x to the 4th, f of 9 minus f of 0. Looks very similar to what we had for the disk method, except I'm multiplying by 2 pi, and we get the same result. Okay, there you go. Hope that helped. If you have any questions, post a comment.